In this video, we're going to take a look at C++'s standard template library support for the stack data structure. The first thing that we'll do is just do a web search for C++ stack so we can find some documentation about the standard template library support for the stack. And the very first result that I got is C++.com's documentation about the stack. And C++.com, I don't have any affiliation with them, but they have really good documentation about the C++ programming language and also the standard template library. So I'm going to go ahead and click on that link there and go to their documentation. So it discusses the stack and the support that the standard template library has for the stack, indicates it's a last in, first out data structure, and it also says that this is a container adapter. So you see here on the very first line in the first paragraph it says container adapter. And what that means is there's another backing data structure. So in the case of the stack, the backing data structure could be a vector, a deck, or a list. And what the stack adapter or container adapter is doing is actually constraining our use of those backing data structures. So in any of those cases, the vector, the deck, or the list, and I know I haven't talked about the deck or the linked list, but I'll cover those in some future videos. But what the container adapter is doing is constraining our use of any of those data structures so that we can only add or push or pop items from one end of a vector or one end of a deck or one end of a linked list. So you could read about the documentation here, and you can also see that we have these member functions. So you have a constructor that allows you to create stacks of any type that you wish. So any of our primitive data types, be it a double, be it a character, be it a float, int, or you could have a stack created for a type that you've created yourself by defining a particular class. So we have that, and we also have our empty function to test whether our stack is empty, a size function that returns the size, top, push, and pop. So these are all the operations that we had discussed in one of my previous videos when I was just discussing the stack abstract data type. So what we're going to do now is go over to Eclipse and write a small program where we make use of the standard template library stack and see how these member functions work. All right, so we're over in Eclipse now, and I've already created a project, and I've also created a CPP file called stack STL. So what we'll do now is just do our pound include. So we'll do a pound include for IOStream, since we'll be making use of cout. And in order to make use of the standard template library stack class, we have to do a pound include for stack. So angle bracket stack. Very much the same as what we did with the vector class when we wanted to make use of the STL vector class. So we'll now do using namespace standard and go ahead and create main. So int main open paren close paren and then open brace close brace. So inside of main, what we want to do is just create a stack, and then once we've created that stack, use our various operations or our functions that's supplied by the stack class. So the push, the pop, the top, size, and empty. So in order to create a stack, we just say stack and then open angle bracket and then specify the type. So the type could once again be anything, so primitive data type, or a type that we've defined or somebody else has defined through some class. In our case, we'll just keep things simple and say int here, close angle bracket, and now we have to specify a name associated with the stack. So we'll just call it my stack. So anytime that we're interested in doing something to the stack, we do it through its name called my stack. And that's pretty much it. This just simply creates an empty stack. So we have that in place, and now what we'll do is push a few things or push a couple of ints onto the stack. So we'll say my stack and then use our dot operator. And so now we get a listing of the various functions associated with the stack. So we'll do, in this case, we want to do a push, and we'll just push maybe the value of 5 and do a semicolon. So that actually pushes the int value of 5 onto our stack called my stack. And I'm going to just copy this line of code and paste it a couple of more times and change up the values. So I'll say that we push on the value of 3, and maybe we push on the value of 2 as well. So we should have 3 values on our stack. So our size of our stack should be of size 3. And we can verify that by using the size function. So I'll do a cout here, and we'll just say number of ints on the stack, and then do an insertion operator, and we'll say my stack dot size open paren close paren, insertion operator, and then an indel. So we've used the push and we've used size. I guess the other three that we need to use is the empty, the top, and the pop. So what we can do is maybe before we pop a particular value off our stack, we can see what that value is by using top. It turns out that if we use pop, we're not going to be able to see what value it is unless we actually use top first. So we could do something like this. We could say cout, insertion operator, and then do popping. Well, let's see. Popping, if I can spell popping. Popping, and then do insertion operator and say my stack dot top. So that just gets the value on the very top of the stack and doesn't actually remove the value, just examines what that value is or returns that value without removing it, without popping it. And then we'll do an indel here. And then we'll say my stack dot pop, and the pop function, it doesn't take an argument. All it's going to do is try to pop whatever our top member is. If we have an empty stack, then it's not going to be able to pop anything. So let's wrap this up maybe in a looping structure. So we can do this. We'll say while our stack's not empty. So we can say while my stack dot empty. Well, I guess we should say not empty. So let me do the not operator here. So we'll say while my stack is not empty, and empty is a function there. So make sure you have open paren, close paren, and then we'll do open brace, and then we'll just tab over this code that we just wrote. So we can say popping, and then we'll pop off some particular value. We can see what that value is by using top, and then we actually pop it. And then I'll do a close brace. So let's just go ahead and save this program for now and build it. See that it builds okay. So it looks like everything is building okay, and now we'll run it. So you can see that whenever we execute this program, it says number of ints on the stack is 3, and then it says popping 2, popping 3, and popping 5. So you can see that the values here are coming off in the exact opposite order that we put them on. And that makes sense, right? Because the stack is a last in, first out data structure. So the last thing that we put in, which was a 2, was the first one that got popped off. I guess the other thing that we could do is, let's do one last thing. Let's take the cout here, and we'll copy it, the one that gives us the size, and we'll paste it down here so we can see what the size of our stack is after we've done all the popping. So let's go ahead and build that again, see that everything builds okay, and run it again. So this time when we run it, we can see that after we push on all those values, the stack size is 3, popping them all off. Now the stack size is 0. So hopefully from this video you learned how to go about using the standard template library support for the stack and how to use some of the operations. In my next video, we're going to look at maybe creating a reverse Polish notation calculator using the stack. So a little bit more substantial use of the stack class. This was a very simplistic use of our stack class just to show how things work. So that's it for this video.